from 7 countries. You guys have been flew more than 5,000 miles to be here, right? Okay, to be the participant of Asian Dreams Competition 2019.
Okay, first of all, let us introduce ourselves. My name is Alda.
And I'm Tami.
And we both are going to lead you in this presentation section. The arrangement of presentation as follows: Universitas Brawijaya,
Tokyo Institute of Technology,
Sri Nakarimiro University,
National Central University,
Universitas 11 Maret,
Mongolian University of Science and Technology,
Mongolian University of Science and Technology School of Civil Engineering and Architecture,
Hanto University,
University of Fukui,
Gifu University,
King Mongkut Institute of Technology at
Universitas Muhammadiyah Yogyakarta,
Kasetsart University Banken Campus,
Tottori University,
Kasetsart University Kampenseng Campus,
and the last one, National Ilan University.
Okay, I know you guys are very excited to see your favorite team, right?
But before you start presentation, let us show you the rules again. You guys only have 5 minutes to explain your bridge. And for your information, our crew will stand over there at the middle. There are our crew. They will remind you when the time is 3 minutes left, and they will remind you again when the time is 1 minute left.
And after your time is up, we will allow you to finish your sentence, and then we will go into question and answer session. We will give you 3 questions, and in case there are more than 3 questions, as long we have more time, we will give another session.
Okay, and during the presentation for the next team, please sit over there, so it makes us easier to call you for the next presentation, right? Okay.
And I would like to inform you of very important things. So you guys here will be the jury for the presentation. And each team will be given 15 assessments as amount of the team. And you have to fill it with score 1 until 4. It is everything all clear and understood?
Everything clear? Clear? Okay. Because everything is clear, and the time is running, so let's start for the first team. But before, for Tokyo Institute of Technology, please sit over there for the next presentation, okay? And please give your warmest welcome to Universitas Brawijaya!
Cái máy chiếu
This is Indonesia, one of the most beautiful countries in the world, with more than 70,000 islands, 740 ethnics, and more than 200 languages, make Indonesia become a multicultural country. From those facts, we should know that every region in Indonesia has different culture, art, and values. Indonesia is also a tropical country, so that Indonesia has a lot of forestry. One of the beautiful places in Indonesia is Kalimantan. The popular ethnic from this island is Dayak. The Dayak people always preserve their culture from the house, clothes, art, and dance. One of the popular dance in Dayak is Mandau dance. Dance symbolizes the fighting spirit of Dayak people and also symbolizes the protection of bring the philosophy of the Mandau, especially the Talawang shield, that is light but strong, efficient, and of course useful. It also has a beautiful look.
So, we proudly present Talawang Bridge.
The Talawang Bridge has 4 types of profiles. The first profile is square hollow section, sound and video for the compression member, and the next profile we use L profile for the diagonal member. In the bridge dimension, our bridge is appropriate with the rules of Asia Steel Bridge Competition 2019. And the third profile is square hollow section for the tensile member and the lateral member. And the last profile is circular hollow section for the top lateral bracing.
So we have the most efficient and optimal design because our fabrication team fabricate the bridge with high precision so that the result can be the same as what we have designed before. On the other side, we also design simple types of connection so that the bridge can be easier to be assembled.
We also practice to assemble the bridge almost every day to get the best assembly time, that is less than 7 minutes. We have 74 bolts and nuts to be assembled in the bridge, and we assemble the bridge from one side to another side. So this is the last step of our assembly method, and to finish, we launch the bridge by 3 contactor to the abutment. After the fabrication, we always test the bridge to know the deflection of the bridge. From the test, we evaluate the result to get the best deflection.
From the aesthetic aspect, Talawang Bridge is a beautiful bridge because it looks like a Talawang shield. We also use 3 meaningful colors for this bridge. First is silver that symbolizes elegance. Second is gold that symbolizes glamour and glory. The last color is blue that symbolizes cool, quiet, but strong. We use this color for this bridge because we hope that this bridge could be the same as the philosophy.
So, this Talawang Bridge is inspired by the culture of Indonesia, especially from Dayak, because we want to introduce the local culture of Indonesia to another country. And from the profile and factors that we use, Talawang Bridge has only 20.7 kilograms, but still optimum enough to hold 400 kilograms of loads. And by the color combination that chosen, Talawang Bridge looks so beautiful and contains aesthetic aspect. Finally, by the creativity and innovation that given to Talawang Bridge has an optimal prediction of deflection. And it's only 6 millimeters.
So, we are University of Brawijaya from Indonesia for the Middle Asia. Thank you.
Okay, that's all about Universitas Brawijaya. And now we're going to the question and answer session. To the audience who want to ask, please raise your hand. Please raise your hand. No one? Is there any question? No. No question? Okay. Okay. Okay.
Are you have backing of a bridge or like a little form? Are you have it?
Excuse me?
So, it's just you have form of it is very high, and you have like this letter of backing. Are you have a letter of backing? We're actually not worried of our bridge of buckling because we have a lateral member so that the buckling maybe can be So I mean, the lateral member can hold the bridge so that the buckling may not be happening in our bridge. Thank you.
Thank you. Any more question?
Okay, sir.
After the competition, if this bridge were loaded to failure, where would it fail? At what location of your bridge would it fail? The weakness of it.
Presenters, please answer.
Excuse me, can I repeat the question? If the bridge is going to be failure, and then?
Where would it fail? What location?
Oh, where's the location?
Or bridge held by the beam, so it might not be failure.
If your bridge were loaded to 600 kilograms,
Okay, 600 kilograms.
where would it fail?
Yeah, honestly, we're actually never test our bridge under 600 kilograms. So by the practice and by evaluation that we give, that we did, we always test the bridge at the maximum load in 400 kilograms of load. So maybe we still don't know where will the failure happen in our bridge if we test it by 600 kilograms of load. Okay, sorry.
Thank you, sir.
Sorry.
Any more question?
Okay, time is up.
Okay, because time is up. Thank you so much, Universitas Brawijaya. Please return back to your seat.
Thank you.
Thank you.
Now we will continue to the second presentation. To the Srinakari mirror, please go to the right side of the stage to prepare your presentation.
Okay. Tokyo Institute of Technology, are you ready? Okay. Please give your warmest welcome to Tokyo Institute of Technology. Good morning. Good morning, everyone. We are students of Tokyo Institute of Technology. We fighting Asia with 5 warriors. Now we begin our presentation. First, our concept is the bridge, which symbolizes Japan and our university. Next year, Japan has Tokyo Olympic 2020. Our university is also located in Tokyo, so we decided the first concept is Tokyo. Next, I explain about our university. In Japan, people call Tokyo Tech is Otaku University, like these images. Otaku means a person who really loves anime, games, manga, and so on. So finally, we reached this concept. The concept is anime and otaku and Tokyo Olympic 2020.
We chose 5 players from anime to fit the concept. The blue is brown. The black is Kaonashi. The red is Mario. The green is the last is yellow.
The answer is Pikachu.
However, we couldn't come up with the design. So we asked Blumen. He's thinking. He seemed to come up with a design. Thank you, Doraemon, for your very good design. The design of our bridge is here. This part expresses Doraemon. This part is Piccolo. This part is Pikachu. This part is Mario. And the horizontal beam is Tamashi.
And Doraemon made really detailed blueprint in order to make bridge quickly and accurately, like this. And joint method is here. First, make holes in square steel and insert the parts and tighten them with bolt and nuts. And we analyze the bridge by abacus. We predict the deflection at measuring point is 6.5 millimeters.
First originality and ingenuity is in order to make subtle angles, we made a foam and put steel materials, the foam and weld it. Second one is paint the hole with white paint before painting with other colors in order to hide the metallic luster and make other colors clearly visible. Next topic is production process of our bridge. First, making a foam. Second, measuring lengths and cutting steel. Third, making holes for bolts. Fourth, connecting steel by welding. And painting the bridge. And finally, we complete it. Finish.
We will do our best to enjoy this Asia Bridge competition. Thank you for listening. Okay! Please give a round of applause!
So we are going to the question and answer session. To the audience who want to ask, please raise your hand.
Any question?
No one want to ask? Okay.
Sao sót vậy? Giờ làm một clip là sót.
It's okay if I ask one question for your team. I saw you present there's
Quê hương
a calculation
hỏi tiếng
use
Nhật
but
cho
that's
nó ngầu
what
vậy.
the result is 6.5 mm for your model. So how is the difference with your analysis and test?
Actually, we did not conduct the loading test. We just did the analysis and the result of the loading is not clearly known in our team.
Sure. You will do the test in the tomorrow.
Yeah.
So you didn't
Này hỏi mà thầy
do it.
thầy hướng dẫn câu hỏi của thầy.
Yes.
Okay.
Okay, thank you, sir. Any more question?
question from connection of your the connection you use on the top in the area of vertical members. What you use what type of your connection?
We use the plate for vertical bridge, vertical members to connect the beams. And the connection of the plate and the beam is done by inserting bolts.
And how many nut and bolts how many bolts you use in this area?
In this area, so you mean the vertical members? Or total number of the bolts?
No. I mean just this area, just I told.
So 4 bolts for connecting the beams and the vertical members, and others for other bolts for connecting the above members.
Okay, thank you very much.
Okay, thank you. Because time's up, please once again give round of applause for Tokyo Institute of Technology.
And now we're going to the third presentation.
For National Central University, please stay over there for preparing your presentation.
Please give your warmest welcome to Srinagar University.
Này của anh. Không biết không?
Hello everyone, we are from Srinagar University. We are so honored to be here as a part of the competition again. This is our team members and our advisors. My name is Choshaba Pudonpo.
And my name is Purika Pitinanon.
And here's our contents of our presentation: concept design, working process, design, structure, joint connection method, and prediction of deflection. For the concept idea, this year our bridge comes under the concept of the myth of swoon. Once upon a time, there was a myth about an albino alligator, or simply known as the white crocodile. Because our university in Onkala campus has a huge pond, which one said, if you not have seen it while you studying there, you would not be able to graduate. However, there is no evidence to prove whether it is real or not, but through the chapters of time, this white crocodile has been used as our university's mascot. This is why we chose it to be our concept, to represent our university.
In problem, since last year competition we had main problem and they were one which was distorted because of the fabrication errors. We also had problem with prediction of deflections because last year it was more than we predicted. Not only that, but regarding to this year rule, we have more challenge because of an increasing of the bridge length and more weight of road. Working process. Therefore, we managed to adjust those problems by we actually to share idea and thought on how to make our bridge better. We plan out sketch design and calculating structural detail. Then we fit detail and we check everything to make sure that our bridge is certified. We managed to get our member done ready to be assembled. After that, we practice and practice. And here comes this year big.
For design, first thing we do after we gather ideas and how to fix our problems was we calculating loading force, compression, and tension force. Then we had shear and bending moment diagrams, which from these we would get the shape of our bridge. And for us, the shape of our bridge is like a crocodile, so it comes under this concept. For colors, as the theme, albino alligator is the white crocodile, therefore our bridge is white-gray.
Structure. Our bridge is a true type truss bridge. Using back steel pipe because it is cheap and lightweight. The bridge contains 46 members. It has a weight of 35.58 kg. The height is 50 cm and the length is 4.56 meters. Using bolt and nut number M6.
Joint connection method. Because of some of our members have length exceeding the specified size. Therefore, we have to cut them shorter. That is why we have more joints between members, which are construction joints. However, we try so hard to make them as one member. We use 2 bolts and nuts for each joint for transferring force and also preventing local bucking. The joint we use is a shear type joint, which sometimes referred to as a friction type or a slip critical joint.
Analysis program. We use many programs in designing this bridge, and they are SketchUp, set up for designing, SAP 2004 predicting the deflection, calculating the bridge, and recheck the structure of the bridge. AutoCAD for drawing each design to see how they look. Excel for calculating joint connection. Prediction of deflections.
Okay, sorry, because the time is up. So we're going to the question and answer session.
Please go forward. Okay, for the audience, anyone going to ask any question?
Là đã cứng cái thời gian của
Please
mình báo
raise
cáo
your
xong
hand.
rồi trong 5 phút đó người ta đổi luôn á. Cái gì? Cái thằng bên này đã tính vậy.
Any question?
Báo cáo là khoảng 3 phút, với 2 phút thôi.
We have about 30 slides.
Okay.
So do you have to continue? So the conclusion is that this year's bridge has been improved from last year. That we have the bridge is stronger, so it can take forces better than last year, and the shorter members has less slenderness ratio, so that prevents the bucking. And the approximately time for construction is about 26.45 minutes, or 1,587 seconds.
Okay, to the next question.
Chị Hoàng. Không, chị nói lại á chị. Có đăng cáp không?
So, how heavy is your bridge?
Đã.
25
Ông nhớ gì nữa?
Sorry.
So the weight of our bridge is 35.58 kilograms.
Okay. Any more questions? Any more questions? No one?
Hi. What's your height?
50 centimeter.
50? Okay.
Okay. Any more questions? Okay, because time is up. So,
We'll continue to the next presentation. So, to the
please give a round of applause for University!
Now we will continue to the
Next presentation, next team for Universitas 11 Malang. Please stay over there for preparing your presentation. And please give your warm welcome to National Central University!
Tụi mình có cần phải la như vậy không? Giờ mấy độ rồi? Gì? Con mấy độ? Mấy độ? Mấy độ gì? Mấy độ? Sao là đen đen? Máy lạnh mà. 52 độ. Đây có
Good morning, ladies and gentlemen. We are from National Central University in Taiwan. The name of our team in Asia Breed competition is Winner Winner Chicken Dinner. In the next 5 minutes, we will introduce our breed.
First of all, I would like to introduce our advisors, Professor Xu and Professor Hong Wenyi. And our teaching assistant, Injariel Saputro.
And then this is our outline, including the concept, process, and features. In concept, we will introduce our design inspiration. In process, we will focus on how we made a breed. In the end, we will introduce our features.
Our concept is from Semanticus Mikado. The special bird only lives in Taiwan. This bird is so famous that we use it as vector pattern in $1,000.
Our inspiration is from the symmetric and aesthetic of the bird. Therefore, we designed the symmetric shape for our breed. Besides, the wing spread provides ideas to design the internal truss.
Also, we use Mikado's color on our breed. For example, we use white color on the end as a bird beak.
And then let's go to the process. First, we use AutoCAD to design our shape, and then analyze in SAP 2000, and then record in Excel, and then do the fabrication and loading test in our lab. In the end, if something wrong, we need to solve the problem and go to AutoCAD redesign again. Firstly, we draw our shape in 3 dimensions in AutoCAD, and this is the length of each member in the picture.
This is the result of force analysis. The minus means compression, and the plus means tension. As you see, we only use compression member on the top side, so our design is very efficient. In section design, we use 2, and the material is SPHT1. As the picture shown, if the color is orange part and below, then we can make sure our member is safe.
And then we check the buckling and yielding in Excel. If the ratio of compression and tension is larger than 1, then we can believe that our section design will be safe.
This is our fabrication photos. We started from cutting, welding, making the welding smooth, and drilling the holes. And then we did a loading test. However, after loading test, we found 2 problems.
The first problem is the connection on the top side is broken, and then the member is not in the same plane. So we draw our shape on the beam need to make sure every member is in the right position, in the same plane.
The other problem is that sway after we put loading bars on the bridge.
So we can always adjust that the knee brace can increase the stability of the building. So we decide to add the knee brace on the top of our bridge.
Okay, let's compare our bridge in recent years. This year, our bridge had a longer span demand and have to carry more weight, but our surface is only 16 kilograms. That is very, very light.
Even though our bridge is very light, after doing a loading test, our deflection is 6.09 millimeters.
And this year, we designed a new connection in the middle of the bridge.
And this is a step to make a connection. We still play to use the bolt, we still play to scratch a member, and then drill the hole together and use the bolt to connect name.
However, to ensure the safety of the connection, we have to test the tensile strength with 100 kilograms. And the result is satisfying.
In the end, we use a new method to decrease the mistake. We cut in the hole in a bigger member and then weld it together. That makes it no need to put a plate there to make it rigid.
And the other method is that we just cut a little bit in the member and bend it. And then this way makes us easier to do the welding and not need a plate either.
In the end, we use animation as our conclusion. We demonstrate our bridge to connect two islands, and then we design our bridge with beautiful Mikado's color, including a white, red, blue, and black. Like the four colors that can represent our Taiwanese kind and passion, and hope everyone will like it.
That's all. Thanks for listening, and hope you have a nice day.
Okay, please give a round of applause for National Central University. We are going to the question and answer session to the audience. Is there any question? No one? Any question? Okay.
For now, we take 11 minutes to construct our bridge.
Chuyện cũng lâu à.
There's more question?
Chắc thêm đợi nữa anh chuyển đợi mấy tuần quay xíu chuyển mấy anh chứ. Đợi tới đợi mình bạn nó đầy được.
I'm very interested in your new connection, so can I ask you after the problem, you make the new connection. So have you seen that type of connection in practice? In practice, in the reality, in the real side of the bridge.
In real side of the bridge. Maybe we just design our new connection in our lab, but maybe the connection can use into a reality bridge, because I think we test our new connection in our lab with 100 kilograms. So I think the connection is work.
Okay, thank you.
Any more question?
Do you use a new connection for the whole of the bridge or only for the tension member?
Yes, it's only in the tension member.
Okay, thank you.
Any more question? No? Time? Okay. No more question? Okay.
Actually, we collect three bridges in the past. So this is the fourth bridge.
Okay, any more question? Enough? That's all from National Central University. Please give applause.
Thank you.
For National Central University, thank you so much. And please return back to your seat. To Mongolian University of Science and Technology, please stand by at the right side of the stage. For Universitas 11 Maret, are you ready? Okay. Please give your warmest welcome to Universitas 11 Maret!
Cái này cỡ hồi trường bộ mình đã nhỏ hơn. Kết nối với điện thoại chép qua được luôn ngoài. Được. Có sử dụng thì mềm gì không? Không.
Hi everyone, my name is Raffi and she is my friend Ingrid. We are from Universitas 11 Maret, Indonesia that consists of 7 members and supervised by Doctor of Engineering Halwan Alvisa. So now, we're going to present you. Bridge is a structure that provides passage over obstacles such as valleys, road terrains, or bodies of water by spanning those obstacles with natural or man-made materials.
In Indonesia, there are thousands of bridges that have been built by the government. And these are several bridges that have beauty in terms of architecture and scenery, and especially the material construction that used is steel. But in order to make a design that has a good structure quality, we face several problems. And the biggest problems are how to transfer load from the upper structure to foundation adequately, and how to avoid members buckling within the structure. In this process of creating a bridge design, first we have to identify the problems by researching literature review. Then it comes to conceptual design. After that, we analyze it using SAP 2000, and we do some evaluations before deciding the final design.
So now, we present you Honai Bridge.
Our bridge is inspired by Papua traditional house. As you can see, the outlook design of the house is quite simple indeed. But the structure is strong enough for keeping the house safe from the impact of the strong wind. Also, the shape of its roof seems like a shape, which is the most stable configuration. Because of that, we apply it to our bridge to create a simple bridge yet strong and stable.
First and foremost, in order to make a design, we use bidirectional evolutionary structure optimizations called BESO 2D. BESO 2D is a software which function is to optimize the structure by gradually eliminating the materials that are not efficient. With BESO 2D, we get such a recommendation for our designs. As we can see from the screen, that the colors indicate the stress value at each part of the bridge. So then, we get this configuration. Specifically, our bridge has 4,600 mm long with a width of 605 mm, while the height of the bridge is 900 mm, and weight itself is 32.72 kilograms. For the materials, basically, we use various types of steel. It consists of two different sizes of pipes and one rectangular hollow. The reason why we use rectangular hollow because it has the greatest moment of inertia than the other shapes. Meanwhile, the pipe ones have the same buckling resistance in all directions. Here, we have innovation for the joint that we use. We use solid steel at its member-to-member connection to reduce stress values and to reduce stress by increasing the area surface. It is also workable and can be ensured that every connection is rigid.
In this case, we use SAP 2000 to analyze and optimize the configuration. But first, we have to input the loads that we use. During the loading process, we put 100 kilos at the quarter and 3/4 span of the bridge, and 200 kilos at the mid span of the bridge. Therefore, we get 0.963 millimeters in deflection, and the PMM ratio shows that our design is efficient enough in structure.
Engineers nowadays need things that are efficient, and our design covers it all with our workable, strong, and stable characteristics of design. We are from Universitas Malang, Indonesia. Thank you for your interest and attention.
Please give applause for Universitas Malang. Now we are going to the question and answer session. To the audience who want to ask, please raise your hand.
Thank you for your team. So your SAP 2000, your results, deflection results was 0.9, but actual real test, what was the deflection, and why do you think this two deflection is different?
Sorry, can you repeat the question?
So what's the difference between analysis deflection results and test deflection results?
Honestly, we haven't conducted any loading test yet, but from the analysis, we get that amount of deflection.
Could you tell us the deflection of deflection?
0.963 millimeters. Okay. Any more question?
So it looked with your solid connections that you were sliding the tube over the solid piece and using 1 volt. So are you using that for both tension and compression connections, or all connections? I apologize for my bad English. So, you're using that connection everywhere?
Okay, thank you for the question. We use, for the member-to-member connection, we use the same style, like that. Like we use solid steel at each member-to-member to reduce the stress by increasing the area surface, like that.
Okay, any more question? Okay, because the time is up. Thank you so much, Universitas 11 Maret. Please give applause once again. Okay. And for Mongolian University of Science and Technology School of Civil Engineering and Architecture, please stay over there for the next presentation. Now, please give your warmest welcome to Mongolian University of Science and Technology.
Hello everybody, we are propagating team of Mongolia, called BRICOM. You probably know about our country by the name of Hindustan. Let me tell you a bit about our country. Our country is the 19th biggest country in the world, and on average our population is just about 3 million. It's much lifting for us compared to many other countries. Construction and structural engineering of our country has been rapidly evolving towards globalization of knowledge of all over the world and easier accessibility. Science our time being heavily defined on the civic units and literature. Our country has nomadic culture for centuries for this culture of development. Mongolia is a country with 4 seasons, and we moving according to our rhythm. We have West Mountains and sandy fields. It's challenging to move constantly due to high cliffs. As such, the bridges. For example, we have the beautiful natures. The examples is Harvard, and this is Solvan's Province, is the most beautiful nature in our country. This is Coastal Lake, it's the biggest lake in our country. Stone, it's the biggest stone in our country. That's true. Name up to the Hanzo. That's your name. As such, the bridge is essential. Our country has a house that can be taken down and rebuilt, colored good. Which is our cultural heritage. There is a component called tongue, which is backdrop as ventilation of the good. The wine is well tolerated and viewability is good. So we have to make the bridge sound as the tongue.
Okay, our bridge is designed to accommodate receiving of the freight through the night. Stretching and compressible elements were chosen to bring vertical placement 5 meters closer. We did the positions of the bridge by hand and computer program, and Maxwell Crimmon diagrams were used to determine the abutment parts, while the vertical placement calculations were done by hand. The placement value was obtained by using Lira Safran 2030 and however, due to the absence of practice, the first bridge build broke down during trial failure. But we corrected our mistakes and built the second bridge. And second bridge challenge is successfully. Okay, what do you think deflection? What do you think deflection? No. My deflection is 5.1 millimeter. Yeah. Okay, this competition has become a beginning of theory and practice and personal team management and many more for us. And despite participating in this competition, we got an opportunity to extend our knowledge and skill through sharing our experiences with you, and we are thankful for that. Thank you for your attention.
Okay, please give applause for Malang University of Science and Technology.
And now we're going to the question and answer session. To the audience who want to ask, please raise your hand.
Tụi mình
Any
đứng
question?
cầm hoài đúng không?
No? Okay.
So your analysis was all by hand and no computers? Your analysis by hand?
We used the Maxwell theorem. We used the Maxwell given the diagram of the used computer.
Software or calculation?
Software?
Yeah, that's a computer software. It's
It's using Russian open their supper.
Any more question? Question? No? No more question?
From there.
I want to ask a question about how about the weight of your bridge? Can you tell us about the weight of your bridge? Thank you.
Can you say it again?
Excuse me?
Can you say it again?
The weight of your bridge.
Wait.
The weight. Yeah.
Our brick weight is 28 kilograms.
We still have more time. To the audience who want to ask.
Any question? No? Okay. Okay, please give applause once again for Malang University of Science and Technology. Thank you so much, President University.
Thank you for extending our knowledge.
We will continue to the next presentation. To the Chanto University, please stand by at the right side of the stage. And please give the warmest welcome to Malang University of Science and Technology School of Civil Engineering and Architecture.
Thì người ta chưa thi nó rồi. Chưa thi nó nhá. Xem chết quá.
Hello everybody, what a beautiful day. We came from Mongolia. Please take your attention. First, idea, trust art. We choose the trust bridge. Why we choosing this? It's using the triangles and the best, strongest shape and whose ball bearing composing the truss and which structure connecting elements using and always forming a triangular piece. Triangular makes a strong structure because it works on compression and tension. By the following rules, our bridge must hold 400 kilograms and length becoming 4.5 meter length. Since the arch form is so effective at spanning a great distance and so effective at spanning a great distance and carrying loads with a reduced deflection, then we combine two types of bridge, truss and arch. This is our designed trussed arch bridge. Our bridge has 69 elements and width is 0.61 meter and height is 0.77 meter and weight is 18 kilograms. Second, aesthetic. We are Asian. In an Asian tradition, tiger represents a beauty, power, incredible strength, courage, patience, independence, harmony, and peace. Tiger will teach you when to move, when to remain still, and at the end, still experience a successful hunt. Whatever your God, energetically tiger as a power and energy animal. From this phenomenon, we painted our bridge similar as a tiger skin, we use orange, white, and black. We hope that this competition will be energetic and harmonious like that the tiger.
Okay, now I will be talking about part of structure. There are numerical analysis and experimental tests. We simulated our bridge SAP 2000 software. We used two types of cross-section. There are square cross-section
Top job is